right, hello everyone. This is Mr. Yane here. I'm just doing kind of a supplemental video here on completing the square. This is kind of one of the more difficult lessons, and so that's why I'm doing a video on it, just because, yeah, I think it'd be good to see it a couple times. But, all right, so background thing is, basically, what we want to do is we want to be able to solve quadratics that aren't easily factorable. Well, so how would I solve a quadratic that's not factorable? Well, one option is that what if I had a perfect square? That's why this thing is called completing the square. So a perfect square would be something like, what if I could possibly get it to the form of x plus a squared equaling some number, right? So if I have this situation, this is actually really easy to solve, right? I mean, basically, x plus a squared equaling some number. We'll call this other number, maybe, I don't know, h. We'll call this h. There we go. So what we'll do is basically what happens is to get rid of a square, we take the square root. So I'm going to take the square root of both sides. And the thing is when you use a square root to get rid of a square, what you have to remember is to use a plus minus on the other side. The reason is somewhat simple and easy to understand. I mean, just think about what if I had x squared equals 9? Well, we easily understand that as, well, the solutions can be both positive 3 and negative 3. And so that's why you need both the positive and negative when you square root the 9, because obviously 3 squared is 9, but also negative 3 squared is 9. So you got to do plus minus here. Now, anyway, once we do the square root, we get x plus a here equals plus or minus the square root of h, and then we can subtract the a over negative a plus or minus the square root of h. Basically, it's pretty easy to isolate this x, right? So if we can get it into x plus a squared form, it would be easy to solve. So if we can get our quadratic into this form, it would be easy to solve. So let's figure out how to get any quadratic into this form. Well, the way you do it is you study what x plus a squared actually is. Well, x plus a squared is x plus a times x plus a. And then, well, let's multiply this thing out just to check out what it looks like. Well, let's distribute the x to the x and the x to the a. I get x squared plus ax. Then I'm going to distribute the a to the x and the a to the a, giving me another ax and an a squared. That, by the way, is x squared plus 2ax plus a squared. Like so, right? Well, this looks pretty good. What we notice is, so again, x plus a squared then is equivalent to this for any number a, okay? So that's the whole idea of completing the square. If I can get something into the form of x squared plus 2ax plus a squared for some number a, I can immediately write x plus a squared. All right, so what does that mean for us when we complete the square? Well, for example, okay, so I'm going to do an example here, hopefully one that's fairly straightforward. By the way, this is on your homework. It's number 2 on homework 3-1, completing the square, okay? So I'm going to use this as an example. So my example here is x squared plus 14x plus 53 equals 0. Well, all right. So I want to get x squared plus 2ax plus a squared, okay? This is what I want. This is what I have. This is what I want. So notice x squared, that matches up. So let's just assume the 14x matches up with the 2ax. In other words, this term stands in for that. Well, if it stands in for that, that means 2a must actually equal 14. In other words, a must be 7, right? If 2a is 14, 2a equals 14. Divide both sides by 2. A must equal 7. So we're going to rewrite this equation so that a is 7 and it looks like this. Well, okay, so if a is 7, we got our x squared, we got our 2ax, because if a is 7, that's 2 times 7, which is 14, so we got that too. But we need plus a squared. A squared, if a is 7, a squared should be 49. So what I want this thing to look like is x squared plus 14x plus 49, right? If a is 7, 2a is the 14, and a squared is 49, right? Now, obviously, these two statements are not equivalent. Specifically, the 53 is not, or sorry, the 53 is not 49. But I can easily make it 49 by simply subtracting 4. But if I subtract 4 on one side of the equation, I gotta do it on the other. This means 53 minus 4 is 49, which is successful, because now I have exactly the form I want. But 0 minus 4 is negative 4. Okay, but notice I have the exact form that I want. I have a squared plus 2a plus a squared as long as a is 7. So if I make a 7, this is what I have. So this is actually perfect. Now note, remember, this, since I now have this, where a is 7, this equals x plus a squared. So this side, in fact, equals x plus 7 squared. Okay? That is the idea of completing the square. We get this into a form that we can actually write, and then we can jump it right back to the x plus a squared. Now, this actually equals negative 4. And then we go through how to solve this. Well, we got to get rid of the square, so we're going to take the square root of both sides. But remember, when you take the square root of both sides, you have to use the plus minus. So this is going to be x plus 7 equals the plus minus square root of negative 4. Taking the square root of this side just gets rid of the square, hence just x plus 7. In taking the square root of negative 4, we have to remember the plus minus square root of negative 4. What is the square root of negative 4? We covered this last time. This is 2i. So this is going to be x plus 7 equals plus or minus 2i. Now when I subtract the 7 across, I get x equals negative 7 plus or minus 2i. This, just like the quadratics that we've been doing, where we can factor, remember the quadratics we were doing when we factored, we had two solutions. This is in fact two solutions. We just write it simultaneously by using the symbol plus minus, and you're totally allowed to do that. So just to make kind of things easier for you. But it is two solutions. It's negative 7 plus 2i and negative 7 minus 2i, right? Okay, so I want to do another example here. So we're going to do one more example. Kind of an easy one, actually. We're actually going to jump back to number 1 on the homework, and we're going to try it out, and then we will move forward from there. But anyway, so let's do number 1 on the homework. So this is number 2. So we're going to do number 1 on the homework. I know that sounds kind of weird to do 1 and then 2, or 2 then 1, but bear with me. Okay, so number 1 on the homework is, it is x squared minus 4x minus 12 equals 0. By the way, this thing is factorable. Right? Whoops. Factorable. Wow, that's terrible. Anyway, let's not even write. Okay, so this thing is factorable. So how is this thing factorable? Well, notice what two numbers multiply to negative 12 and add to negative 4. Well, those two numbers are 6 and 2, and so we get x minus 6 and x plus 2, and that's going to equal 0, and so x equals 6 and negative 2. So we actually know the answer by factoring. So this is clearly way easier to do by factoring, but we are going to do it by completing the square. We should get the exact same answers. So remember, completing the square, the whole idea behind completing the square is that x squared plus 2ax plus a squared equals x plus a squared. So I'm going to get it into this form, and then I'm going to write this. That's the whole idea of completing the square. Get it into this form, get it looking, then you can switch it into this. Well, I have a negative 4 as a coefficient of x. Well, basically, this says that negative 4 then must be taking the place of my 2a. In other words, a must be negative 2. Divide that by negative 2. So, recap. First step, figure out what your a is. Your a is this thing divided by 2. So negative 4 divided by 2 is negative 2. Second step, figure out what your a squared is. Well, once you know that a is negative 2, your a squared is 4, because negative 2 squared is positive 4. That means what we need here is we need an x squared minus 4x plus 4 equaling something else, right? I have a negative 12. I need a plus 4. Well, what would I do to make a negative 12 a positive 4? I would add 16. So I get 16 over here. Now, I have this situation, because that's how I planned it, which means I can rewrite it as x plus a being negative 2. So this is actually going to be x minus 2 squared equaling 16. Take the square root of both sides. X minus 2 equals plus or minus the square root of 16. Add the 2 over. X equals, I'm going to add the 2 over. Boom. I'm also going to actually take the square root of 16, which is 4. So I get 2 plus 4 and 2 minus 4, right? Well, 2 plus 4 is 6. 2 minus 4 is negative 2. Notice I got the exact same answer than when I factored it. So factoring, clearly easier, but completing the square always works, even when it's not factorable, but it also works when it is. So let's say you're looking at a problem, you don't see the numbers to solve it, you're not sure if this thing is factorable. If you complete the square, you will always get the answer, whether or not the quadratic is factorable. Nice. Okay, I am going to do, let's see, let's do one, should I do another example? Give me a second. We're gonna do one more example. This is just an example. This is not a homework problem. So this is just an example. And this example I'm gonna do x squared minus 6x plus 17 equaling 0. Okay, so to do this example, again, I need x squared plus 2ax plus a squared. And that's going to equal x plus a squared, like that. Okay, now, well, this means 2a must equal negative 6, because that's the x term, right? That means that a must equal negative 3. And that also means that a squared must equal 9. So these are the three numbers that you need to know, right? You need to recognize the middle term, negative 6. Then what you want to do is you want to divide that term by 2 to get your actual a, that's negative 3, and then you want to square it to get 9. That means that what we actually want here is x squared minus 6x plus 9. Well, I have 17. I need 9. Well, that means I'm going to simply subtract 8. But if I subtract 8 from one side, I have to subtract 8 from the other. So now I get x squared minus 6x plus 9 equals negative 8. Now I know that x squared plus, now I know that since I've gotten this situation going though, it's just going to equal x plus a squared. Well, if it equals x plus a squared and a is negative 3, this thing equals x minus 3 squared. And that's going to equal negative 8. Again, square root, x minus 3 equals plus or minus the square root of negative 8. By the way, negative 8, when I take the square root of that, I actually can reduce that. What perfect square comes out of negative 8? And hopefully you recognize negative 4 times 2. So I'm actually going to be taking the square root of negative 4 times 2. Square root of negative 4, though, comes to the outside as 2i. So I now have x minus 3 equals plus or minus 2i square root of 2. Move the 3 over by adding it, since it's x minus 3, I get x equals 3 plus or minus 2i radical 2. I cannot combine these two terms. 1, because this term is imaginary, this term is real. And 2, this term has a radical 2. And so it's in terms of radical 2. This is just an integer. We also can't add it for that reason. So that's going to be your answer. So that's a good example of completing the square. I'm going to stop this video now, but I do plan on giving you a couple more examples in a bit. So hope you enjoyed this video. Thanks.